Lee, you're looking good today.
Well, thank you, Mike. Looking to happy yourself. The reason I'm all gussied up like this is because astronomers just found the source of essentially all the gold in the universe, and it comes from colliding neutron stars.
Neutron stars, those are stars that have collapsed to such a density that they're basically just a single giant atomic nucleus made up of neutrons, and so dense that a teaspoonful of their substance would weigh as much as Mount Everest, or maybe more. Crazy stuff. The way we found these things is by looking for gravitational waves. You remember last year when we detected gravitational waves from colliding black holes. That was very exciting. Vindicated a prediction made by Einstein. But the problem is black holes are black. You can't see them.
So in this case, the same groups discovered colliding neutron stars via gravitational waves, and that set off a frenzy, a gold rush, if you will, to look at these things in the sky, because the gravitational waves were able to tell them where to point the telescopes to see normal light spilling out of it in a big flash.
Gigantic explosion.
And so we're talking more than 70 observatories all around the world got in on this. They looked at these things with every conceivable wavelength. They looked at them in radio waves.
They looked at them in infrared.
They looked at them in X-rays.
And visible light.
And ultraviolet.
And gamma rays.
Is that all of them?
I think we ran out.
Yeah.
And it was this huge flash of light across all of these wavelengths. Because they got such a comprehensive picture of how this thing unfolded, they were able to test their theories about where heavy elements come from. Now, light elements,
they come from the Big Bang, and slightly heavier things like carbon or oxygen or nitrogen, those come from nuclear fusion in stars. But the really heavy stuff, the uranium, the palladium, the platinum, the gold, that stuff, we didn't really know where it came from. And it's real heavy because of all the neutrons that are in it. So neutron stars are a natural place to look.
And finally, we got a chance to look. And sure enough, the way the light played out from this explosion vindicated that theory.
The only really good way to explain the evolution of the light, the way it went from changed in color and temperature, is by this process creating very heavy elements. And when we talk about heavy elements, it's happening very fast and it's happening on very large scales.
It wasn't just a little bit of gold.
It was a lot of gold. It was so much gold, in fact, we're talking hundreds of Earth masses per event. And when you do the math and you look at the number of mergers that take place across the universe, if each one is making this much gold, it explains all the gold and other elements we see in stars and planets and so on and so forth.
And the beauty is that we're going to see a lot more of these mergers with gravitational wave observatories, going to look at them in telescopes, and understand this process in much greater detail. For Scientific American, I'm Mike Lemonick.
I'm Lee Billings.
Please subscribe to our YouTube channel.